Very good morning to all. I am Dr. Devasis Mohanty, working as Assistant Professor in the Department of Mathematics, SR University, Warangal, Telangana, India. So today I am going to teach you about the normal distribution. So here the details of the normal distribution is given. That is that is a continuous probability distribution, and that is symmetric around the mean. So it is about the symmetric around the mean. That is symmetric around the mean. Okay, students. So here it is the important formula, that is f of x mu and sigma, that is equals to 1 by sigma into 1 by sigma into square root of 2 pi, that is e raised to the power minus x minus mu square divided by 2 sigma square. This is the formula we are using for normal distribution. And here two important characterization of the parameters, that is the mean, that is this is the important, that is the mean is in center of the distribution, and standard deviation, that is about that represent the spread in the curve. Next, coming to the characteristics of the normal distribution. So the important characteristic is that mean equals to median equals to mode. Okay, mean, median, mode are same in case of normal distribution. Why? Because it is about the symmetric nature around the mean. So uh, the mean is mode and median are same. Next thing is that it is bell shaped. So that is very important. It is a bell shaped. What is the meaning of bell shape? So here the bell shape means this shape is called as bell shaped. Okay. So this is about the bell shape and asymptotic nature. So asymptotic, it is the nature is asymptotic. So there is a 68, 95, and 99.7 rule. So when it is the 68%, here you can see when it is 68%, the mean is mu plus or minus sigma. That means one standard deviation is there. And 95% data falls in two standard deviation, that is mu plus or minus 2 sigma. And 99.7, that is mu plus or minus 3 sigma. So these are actual the values we are getting to find here. Next is the normal distribution, graphically representation of the normal distribution. So that is very important, students, because here it represents about the normal distribution, that is about 68%. Here you can see that is 68% and 95% and 99.7%. So here we can see the mean mu, the variation in the mean mu. So that is mu that varies from 1150 that towards mu plus 2 sigma, mu plus 3 sigma, like that. So, and in the left side, that is mu minus sigma, mu minus 2 sigma, mu minus 3 sigma, like that also. So this is the graphical representation of the normal distribution, and how mean is representing the normal distribution with the variance in the 68%, 95%, and 99.7%. Okay, students. So here you can see the variation. Next, coming to the graphical representation, that is the bell curve. Here it is very important. Bell curve. Bell curve means here you can see it is the average is there. This is the average. This is the high average. High average means above the average. So if the average is 100, here you can see if the average is 100, it will be increasing like that. 110, 120, 130. And similarly, here the average is gradually decreases with 90, 80, and 70. Okay, students. So this is scaled around the bell curve of the normal distribution, we can say. Next, coming to very important thing, that is the standard normal distribution. Standard normal distribution. So here the probability, you can see the probability of x less than equal to z, that is represented as integration minus infinity to z 1 by square root of 2 pi e raised to the power minus t square by 2 into dt. But here one important thing is the z-score calculation, that is x minus mu, here it is. the z value. Here we are calculating the z value. Z equals to x minus mu divided by sigma. So that is very important. X minus mu divided by sigma. This formula. This formula is important. Okay, students. Next, coming to the standard normal distribution, means here we can see that the standard normal distribution, the that represents equal distribution, means if the right hand side is 34.1%, you will see that curve. That is, if this right side is 34.1, so 13.5, here also 13.6, a little bit. So 2.1 means here also 2.1. So that is equally distributed. Here it is a standard normal distribution. Next, coming to the probability density. Here, one standard deviation. That means here the color is represented as green color. Here we can see that 0.68. And here also that is pink color. That is 0.95. And that here it is, that is the blue color that represents three standard deviation. So here it is representing the variation in the standard deviation with respect to the probabilistic density. Okay, students. So now coming to the important thing, that is mu plus or minus sigma. Here we can see that is mu plus or minus sigma. Mu plus or minus sigma, that represents the single mean, and mu plus or minus 2 sigma, that represents the pink color. Here you can see the pink color. Okay, and mu, this represents the mu plus or minus 3 sigma, that represents the blue color. Okay, three standard deviation. Next, coming to, this is the normal distribution table. Actually, this is the normal distribution table. Normal distribution table. Using this table, we will calculate actually. Okay, students. So here you can calculate. This is the normal distribution table. Here you can calculate these values using the Z score. Means Z value, we can calculate the normal distribution. So this is for negative values. This is for positive values. So next important thing is the table of the standard normal probability for positive Z score and for negative Z score. So for positive Z score, we can see the color means it is approaching towards the axis, and for negative Z score, you can see here it is small portion is affected by the negative Z score. So here it is the variation, you can see this to this, the variation is there for positive and negative. So students, this is one example is given for you. So how to solve this problem using the normal distribution table, we will see here. This is very important. So here what is given here? The height. It is given the height of the students. Height of the students. It is given about the height of the student. So here we need to calculate that has a height greater than 175, and in the below part we are calculating the height between 160 and 180 centimeters. So when you are calculating that, we need to let me erase this first so I can explain here. So when you are calculating, so here the x value, that is equal to 175 centimeter. This is the x value. Okay, because we are calculating the height greater than, that is greater than 175 centimeter. We need to calculate. First of all, read the question carefully. The heights of students in a college follow a normal distribution with a mean of 170 centimeters. So mean mu equals to, here mean mu equals to 170 centimeters. And the standard deviation sigma value is equal to 6 centimeters. So mean is given 170 and sigma is given 6 centimeters. Now we need to calculate the Z score, that is Z equals to x minus mu divided by sigma. So here, what is the x value? X value is 175 minus, what is the mu value? Mu value is 170 divided by What is the standard deviation is given? 6. So that equals to 5 divided by 6. That equals to 0.83, right? So here you are getting this value 0.83. Let's see the solution. Yes, here you are getting this value. 0. Here this value is given 0.8333. Now tell me, we need to calculate the probability of z less than equal to 0.83. Using that table only, we'll get 0.7967, right? So after getting this value, here you see, because we are going to calculate the greater than the value of 175 centimeter. So greater than that value of 175 centimeter means we need to subtract it from 1, because the total area of curve is 1. So from that we need to subtract, and we are finding that result 0.2033. That means 1 minus 0.7967. That value is representing as 0.2033. That means, or we can write that is as 20. Here you can see this value. Okay, that is 20.33%. Also, you can write this 20.33%. Okay, students, understood? So this is actually the has a height greater than 175 centimeters. Next, coming to second question, has a height between 160 and 180 centimeters. So when you are going to calculate this as a height of 160 or 180, when you are going to calculate this, so you need to see first of all 160 centimeter. What is 160 centimeter? That is the external value, because the height in between 160 and 180 we need to calculate here, right? Right, students? So now tell me, let me erase this. Okay, now tell me, if it is 160 centimeters, so what we need to calculate? The Z1 value. Z1 value, that is Z1 equals to what? Yes. So here Z1 equals to that is x1 minus mu divided by sigma. Here x1 value equals to 160. Similarly Z2 equals to x2 minus mu divided by sigma. And here we can see the x1 value equals to 160, the x2 value equals to 180. That is 180. Okay. So here, as the x1 value is 160 and x2 value is 180, so we'll apply this formula only. So I'll show you the solution. So this is the solution actually. Here x1 value is 160 and x2 value is, you can see here, 180. So after looking after these values, when we can calculate the z1 also, because using the formula x minus mu divided by sigma, but here it will be x1 minus mu divided by sigma, because we have between two heights we need to calculate using the normal distribution, right? So here that z1 value, that is, here you can see here the z1 value is 0 minus 1.67 and z2 value is 1.67. So again in the below part you can see the probability of z less than equal to 1.67 is 0.0475. Similarly, probability of z less than equal to 1.67 is 0.9525. So here you can see the probability of the two heights 160 and 180. So 160 less than x less than 180. So this value you will get 0.905 after subtracting this value from 0.95 minus 0.04. You will get this value, right? So this is 0.90, that value 0.905, that represents about 90.5%. 90.5%. Okay, students. So this is the height. So this is about the first question. Okay, so any doubt, please ask. Because here the variables already that x1 and x2 values given means you need to calculate the height between 160 and 180. So whenever we are calculating for 160, that is the x1 value is 160. And again, when the mean you are applying, same mean and same standard deviation. But here we cannot take only x value because between two given values you need to calculate between 160 and 170. So that's why we are using that 160 as x1, 180 as x2. Okay, understood? Okay. Next, coming to the next question. So this question, try to read this question carefully. The time taken by students to complete an exam follows a normal distribution with mean of 90 minutes and a standard deviation of 15 minutes. So here the mean is given as 90, standard deviation is given as standard deviation is 15 minutes. Okay. So find the probability that a randomly selected student completes the exam in less than 75 minutes. So you need to compute the probability here less than 75 minutes. So how to compute? We need to calculate the z value, that is x minus mu divided by sigma. Formula will apply. So for that probability, we need to find probability of x less than equal to 75, right? So here we will apply this formula. So 75 minus x minus mu. What is the value of mu? That means mean is 90 divided by 15. That is equal to minus 15 divided by 15. So that value will get minus 1. Right. So for that minus 1, we need to check that normal distribution table. So what is the value for minus 1? So that we can calculate the probability. So let's coming to the solution part. Here you can see probability, you will get z value as z value equals to minus 1. Again, after finding the z value as minus 1, we need to calculate the probability of z less than equal to 1 minus 1.0 minus 1.0, right? So how to calculate that? Using that normal distribution table, that is 0.1587. Okay, clearly understood. So this 0.1587 means that is nearly equal to 15.8%. Here you can see. Here you can see the complete. Here you can see the complete one. Okay, students. So because in the question it is mentioned, you have to find, you have to when the exam is completed in less than 75 minutes. So for that only we need to see here. The mean is given 90 minutes and the standard deviation is given 15 minutes, right? So for that only you are finding this complete the exam in 75 minutes. You are using the normal distribution table again. So using the normal distribution table means here you will get that value 0.15 0.1587. That is nearly 15.87%. You are getting this result you are getting, right? So whenever some number is given means you think that a variable is given and how we will implement and how we will find the z score. After finding the z score, then so z value means here it is 1.0. So that we have to check the normal distribution table because we need to find the probability of z less than equal to that value minus 1.0. So that is the case for normal distribution. That is very important here. So here that value you are getting whenever you will see the normal distribution table minus 1.0 value is 0.1587 you will get. Okay. Next coming to the important, that is the second question. Takes between 85 and 110 minutes to complete the exam. So we have to see that. To complete the exam that takes between 85 and 85 and 110 minutes. So this second question is very interesting. So let's see. Okay, here you can see the second question solution. So here you will see you have two variables because we need to calculate for 85 also and we need to calculate for 110 also. So for 85, how to calculate? Using the formula x1 minus mu divided by sigma. For 110, how to calculate? X2 minus mu divided by sigma. So X1 minus mu is 85 minus 90 divided by 15. That is minus 0.33. Okay. Again for Z2, this is the Z1 value. Again Z2 value when you are calculating, that is 110 minus 90 divided by 15, because the height is given 110, and in case of this is 85. So that value you are finding, that is 1.33. For one case you are finding 0.33. For one case you are finding 1.33. Right. So when you are finding these two values, that is minus 0.33, and again Z2 value you are finding 1.33. So you need to check here. Here you can see. You need to check here. So probability of Z less than equal to 1.33, that value will get 0.90. Again, when you are finding this value, probability of Z less than equal to minus 0.33, that value we are finding 0.3707. Right. So in this way, you can find that between two values. So whenever two values will be given, then you have to consider two, means Z score, that is Z1 and Z2. And for considering Z1 and Z2, with the same mean and standard deviation you are using. Okay, students, okay, it is clear. Now, whenever, but the variable we are using X1 is the first, that is 85, and for X2 is 110. Okay, so that's only we need to calculate here. And here you can see that probability of 85 less than x less than 110, that value. So here this value, that is equal to 0. Here you can see here 0. That is 5375. Okay, that value you will get final. Okay, student. Next, coming to the another problem. So here it is about the application of the normal distribution. So in the application part, we can see here. First of all, read the question carefully. Okay, what the question is asking about? The question is asking about, suppose the current measurements in a straight of where are as sum to follow a normal distribution with a mean of 10 milliamperes. So 10 milliampere is the mean is given, and variance is given 4 milliamperes. So first of all, write the given things here. Mu equals to 10. That is the mean milliampere. Again, variance. Variance means sigma square equals to 4. So if sigma square equals to 4, then sigma value will be what? 2, 2 milliampere, right? So now from this question, we gather the information about the mean, mu equals to 10 milliampere, and the variance, that is equals to 2 milliampere. Now we have to understand the question, what the question is asking about. What is the probability that a measurement will exceed 13 milliamperes? So that we need to calculate now. So to calculate exceed 13 minutes, 13 milliampere. So for that, we need the x value. We can take here the x value, that is 13. Okay. Next, by taking these values, next is we need to calculate the z value. So z equals to, we know the formula x minus mu divided by sigma. So here you can try to understand the question. So whenever you are getting the z value x minus mu divided by sigma, so here you will apply the x value. X value is equals to 13, right? X value equals to 13. Next, coming to the solution, here you can see x value is 13. So z equals to, here you will find the z value equals to 13 minus 10 divided by 2. That is 3 by 2. That is 1.5. Okay, that is 1.5. So here you can see the result. That value is 1.5. So that value probability of x less than 13 is equals to, that we can calculate the probability that z, will take the z value, z greater than 1.5, and probability of z less than equals to 1.5 using the normal distribution table, we are getting the nearly equals to 0.9332. This way you can see here. Now after coming to this, we'll find the z probability of z less than 1.5. So that is very important. Probability of z greater than 1.5. That value we need to calculate, because we need to calculate that exceed 13 milliampere. So exceed 13 milliampere, here we can find that is 1 minus 0.9332. That value will get 0.0668. Okay. So this is about exceeding 13 milliampere. So this is one question from the application of the normal distribution. So in any case of application, we can use this value actually. So by using this value, we'll find that probability of z greater than 1.5, this value is equals to, here you can see that is 0.06, 0.0668. That value you will find. Okay, so this is all about that question. Next, coming to the next question. This question is very important for you students because this is explaining about the current measurement. This is also one application. This is also application of the normal distribution. This is also application. So here for this application, what the data is given, first we need to understand. So the data is given. Try to read the question carefully. The current measurement in a strip of wire follow a normal distribution with a mean of 10 m. So here the mu value equals to 10 m, milliampere. Again, what given standard deviation, sigma equals to 2 m. So mean is given 10 m and sigma is given 2 m, 2 milliampere. So with this data, given data, we need to calculate what is the probability that measurement is between 9 milliampere and 11 milliampere. So between this value we need to calculate. So you will also use this same value. Z1 equals to x1 minus mu divided by sigma. Z2 equals to x2 minus mu divided by sigma. So for Z1, we need to find the value that is for x1 is given 9 minus mu value. Mu value is 10 divided by sigma value is 2. That is minus 1 by 2. That is equal to minus 0.5. Again plus Z2 will get 11 minus 10 divided by 2. That is the positive number will get, that is 1 by 2, that is equal to 0.5. So for one case we are getting 0.5, for another case we are getting minus 0.5. Okay students, so here we can see here Z1 value equals to, that Z1 is equal to 0. Minus 0.5. Again Z2 value equals to 0.5. So for one case we are getting negative, for one case we are getting positive. So for that case we need to, when we are calculating the probability of z less than equal to 0.5 minus 0.5, and in the second case we need to calculate the probability of z less than equal to 0.5. For two cases we need to calculate the value. So let's come into the solution part. Here you can see that solution part. So solution part, try to understand the solution part. First convert to z score. So this is the step one. This is the first step, right? Convert the z score. So first step is convert to z score. Okay, so convert to z score. Here we need to use this formula, z equals to x minus mu divided by sigma, that is x minus, what is the mu here? That is 10. What is the sigma value? That is 2. So x minus 10 divided by 2 you will get here. So whenever we are calculating z1, then we will apply this x1 minus mu divided by sigma. When you will calculate z2 value, that will apply x2 minus mu divided by sigma. Same formula you will get, x2 minus mu divided by sigma. Okay. So whenever we will calculate this two value, so here we will get then at last the z1 value we are getting, that you can see here the z1 value is 0 minus 0.5 and z2 value is 0.5. So already I have discussed about it. So here we need to calculate the probability, that is 9 is less than x less than 11. Means that value between 9 and 11. So that is very important. So for 9 we are getting that probability, that is minus 0.5. Less than x means we need to convert then again to z. Less than 11 means for 11 we are getting 0.5. Minus 0.5 to 0.5, two values we will calculate here. Okay students, next coming to the solution. So after calculating these values, next we need to see that now from the Z table, we need to see this value. So here we will see the probability of Z less than 0.5. That using the normal distribution table, we are getting 0.69146, right? Again, when we are calculating the probability of Z less than 0.5, minus 0.5. So in case of any minus 0.5, again we are getting using the normal distribution table, that is 0.30854. Okay, students. So after calculating both, we need to calculate the probability of minus 0.5 less than Z less than 0.5. That value will get 0.3829, or the current we can say that is about 38.3%. The current is about 38.3%. Okay, students, everyone understood? So this is about the measurement between, this is the measurement. This is the measurement between 9 milliampere and 11 milliampere, right? Okay, next coming to the next question. Find the current value below 98% of measurements fall. The second question. So here you will see the solution of the second question. Here given 98% that will fall. So 98% for current will fall means we need to calculate the probability of capital X less than small x. That is equal to 0.98. That means 98%. So for that only, we need to calculate the probability of x minus, what is the mean? 10 divided by the standard deviation is 2. That is less than x minus 10 divided by 2. That value will get here 0.98. And to calculate this value, we need to see that x minus 10 divided by 2, that value is equal to. So we need to see again that normal distribution table. What is the normal distribution table? We need to see where the value of z is nearly equals to 0.98. So here it is given something, means that nearly equals to 0.98 means 0.97982. That z value is less than 2.05. So for that only, the x minus 10 divided by 2, that is equal to, we are taking the value 0.2.05. So 2.05, this is the x minus 10 divided by 2. So here we will calculate the x value as, that is 10 plus 4.10. From this, we will get, that is 14.1 milliampere. Okay, students. Now you are getting what I want to explain it. So whenever the 98% current measurement will come, so that will be definitely below 14.1 milliampere. So here in this question, actually we need to calculate the x value. So for calculating the x value, the data is given 98% measure that current falls. So here you try to see the question. That is, the current value is below 98%. So below 98% means that current is given below 98%. So below 98% case, we are getting that below 98% 0.98, that value we are getting, that is 14.1 milliampere. Okay, students. So this is about, so this is the above requested value that is shown graphically in below figure. Okay. So here what we observe that in the first graph, here we see that this first graph. This first graph is explaining about that z equals to x minus 10 divided by 2. So here you can see here how much is affected. How much is affected. So this one, up to this much is affected. Right? Why? Because this is 2.05. After the implementing the 98%, this is the normal, using the normal distribution table. Using that normal distribution table, we are getting this value that is affecting around the axis, that positive z score that is affecting. Both are positive because 2.05 and 0.98. But the like the shape, there is a change in the shape. So here in the second way when you are getting, that is 0.98. So that is only you are finding here. Okay. So 0.98 we are finding another one, and for z value we are finding another one, right? Okay, students. So here, after all these things, we have some practice problems. So try to read this question carefully. A food packaging line fails line fills bags of rice, and the weight of the bag follows a normal distribution with the mean of 10 kg. So here the mean is given. The mean is, that is the upper part, we will see that part is given, that is the 10 kg, and the standard deviation is 2 kg. So determine the following probabilities. What is the probability of randomly selected? That is 13 kg. And again for 9 kg. Again between 6 kg and 14 kg. Again 2 kg and 4 kg. Again minus 2 kg and 8 kg. So you need to calculate all these values. So here try to understand the question. When the mean is given 10 equal to 10 kg, and standard deviation sigma is 2 kg. So whenever the mean is given 10 kg and standard deviation is given 2 kg, so here we'll apply this formula. What is the formula? That calculating the z score. That is x minus mu divided by sigma, right? So when you are implementing these things, so you will definitely x means less than 13 kg. So less than 13 kg means what we need to calculate here? That z is less than equal to 13. That we need to calculate. So using this formula, that is x minus mu, 13 will take 13 minus mu is 10 divided by 2, 3 by 2, 1.5. For 1.5, we will calculate the z value again. It is z is less than equal to 1.5. Okay, students. So for that, we will get the result as that is 0.9. So again, in the second question, it is asking about what is the probability that a randomly selected bag that weighs more than 9 kg. Okay. So more than 9 kg means what we need to calculate. More than 9 kg means that we need to calculate the probability that x greater than 9. Okay, so probability again for that only the mean is given 10 kg. So we need to calculate again for 9, more than 9. So 9 minus 10 divided by 2, that is minus 1 by 2, you'll get minus 0.5. So for that only again we need to calculate the probability. We need to convert into z value, z score calculation. So z is less than equal to minus 0.5. We need to implement this value and find. Similarly, we'll do all these problems. So I have also written the answer. These are the answers also written for you. Okay, just to verify these answers and try to solve this problem. This is the answer of the first question, that is 0.93319, and the second question, that is 0.69146, and third question is 0.9545, and fourth question is 0.00132, and the last question is 0.15866. Okay, students. So these are the answers of the questions. Next, coming to these are the practice problems. So you can practice these questions for exam. So next is given a delivery services, delivery time follows a normal distribution with a mean of 5 hours and standard deviation of 4 hours. So we have to determine what is the probability that a delivery takes less than 11 hours. So less than 11 hour, we need to calculate the probability. Again in the second question, so less than 11 hour means the mean is given, that is 5, and standard deviation 6 is mu is given 4 hours, right? Mean is given 5, standard deviation is given 4. So you need to calculate the probability that x less than 11 hours. So for that we need to calculate the z value, 11 minus 5 divided by 4. Okay, 6 divided by 4. So that, so I am giving one hint for you. So that is the way you have to solve actually. Okay. Now, in the second question, it is given the probability that a delivery takes more than 0 hours. So for more than 0 hours means we need to use same formula. So here is the answer for all questions. So these are the answers actually. Okay, for the all the questions. So for 0 point for the first question, 0.93319. Second question is 0.89435. Third question is 0.38292. Fourth question is 0.80128, and fifth question is 0.54674. So this is all about the that practice problem. Okay, students. So here, before complete this class, so I'll explain how to use this standard deviation table. This table is very important. This is the normal distribution table. This is the standardized normal distribution table. How to use that table to find the z score. So that is very important for you. So here you see this is for positive z value, this table. So in this table, the positive z value is there. So positive z value, I'll show you positive z value. So here z positive value starting from 0.0 to 3.4. Okay. So here suppose that value is given 0.52. Suppose we need to calculate the probability of z is less than 0.52. So how we'll calculate this? This will calculate that is 0.5 plus 0.02 by using this 0.02 by using this table. So 0.5 is already there. 0.5 you need to see 0.02 what is the value? That is 0.6985. This is the value of 0.52. This is the value of 0.53. This is the value of 0.54. This is the value of 0.55. This is the value of 0.56. This is the value of 0.57. This is the value of 0.58. This is the value of 0.59. Similarly for all 0.61, 0.62, 0.63, like that. So whenever we are finding any, suppose we are finding 0.555. So for that only we need to see here 0.55 value is 0.7088. So this values in question it will be given the z value. So no need to worry about that. But you have to understand this normal distribution table properly, because whenever you are going to calculating the z score, so that z value is very important to look after it. Otherwise, you cannot find this value and how this value are implementing to find. So it is given up to 3.4. Okay, so more value you try to find. Next is this is the negative z score for the negative z score. So when the value z value is minus 3.4 and coming from minus 0.0. So whenever you are calculating, suppose minus 3.3 you need to calculate. So that you have to see that minus 3, that value minus 3.0 of 0.03. So we'll find that is 0.001. So only by this way we can see and we can verify and we can check the normal distribution table for implementing in the problem and how to solve that. So here in the question, I'll show you this question. Please try to see. We need to calculate the probability, that part only that part. Probability of z less than equal to 0.83. How this value is coming? 0.7967. How this value is coming from this value, from this 0.8. Let's see. Let's see. So 0.83. So here we will see 0.8 plus 0.03. So 0.8 at the position of 0.03 we need to see. So that value is 0. So here we will 0.8, that is 0.03. So here we will get this value 0.8, 0.03. Okay. So that is 0.7967. Okay, students. So again, whenever the second one is that this value, look after this value, this probability of z less than equal to minus 1.67. That value we are getting 0.0475. Again, for positive 1.16, again we are getting 0.9525. So this is the way actually how we are using this z score. Okay, using this table only, this tabular value using. So we are basically focusing this table value. This is the normal distribution table. Save it in your system so that you can get that z value. Actually, for the z value, what you need to do, we can find here. Okay, students. So for z less than equal to 0.83, you will get 0.7967. Similarly, for z less than equal to minus 1.67, you will get 0.0475. Again, for probability of z less than equal to 1.67, we will get 0.9525. So this is the way we are calculating the z value. Okay, students. So this question also we have solved. We have seen that how we are going to use the z value. This is the application question, application of the normal distribution. So in this question also, I have explained that how for the measuring the current, how we are going to implement the mean, how we are going to implement the variance. Means if the here it is given the variance, here it is given the variance. Variance equal to 4. So variance equal to 4 means what is there? Sigma square value is 4. So if sigma square is 4, the sigma value will be obviously 2 milliampere. That means the square root of the variance, obviously. From that, we will get the standard deviation. Sigma means standard deviation will get 2 milliampere from that data. And already it is mentioned about the mean. What is the mean here? The mean is already given here. Here the mean is given, right? Here the mean is given. That is 10 milliamperes. So mean is given 10. Here mean equals to 10 and sigma value equals to 2. From that only we need to calculate. Suppose this question is given 13 milliampere, we need to calculate. So Z value will calculate 13 minus 10 divided by 2. That is 3 by 2. That is 1.5. Okay. So these questions already I have discussed. So any doubt, any question, please ask me. Again, you can see here, again, the measurement follows this normal distribution. Mu value is 10 milliampere, sigma square is 4. All this data are given. And final answer is you will get here 0.0668. Okay. So again, second problem also we can see here the mean is 10 milliampere and standard deviation. Already I have discussed about it. So this is the way to solve the problem. 98 will get this. These are the practice problems. So we need to practice these questions. Okay, and practice for the exam also. How the exam you will write the questions like that. You can get more score in this question. So try to practice about that. Okay, students. So thank you for listening about this lecture. So anyone having any doubt, please ask me in the class so that I can explain it more. So basically, normal distribution means using this normal distribution table, we are going to calculate the z value. Why we are calculating? So these characteristics are explaining that bell shape. So to find the average and all these things, so already it is here. To find the average here in this figure you can see here the average is like that, and here it is about the low average, it is about the high average, and it is above the high. You can see the last part is also well above the high is 1 and well below average is 1. So here it is, you can relate. Here it is 3, here it is 3. Here it is total number is how much? 7. Here also total number is 7. So equally from this total average, equally to low average, equally to high average, equally to below average, equally to above average, equal to that well below average, and that is equal with the well above average. So with the scale score also given, that is 1 to 3, that standard score is 74 to 586 to 790. So this is all about the equally distributing data. Using the Z score calculation, we can calculate this way. And it has a huge application. So whenever we're calculating a large data set, so it is very helpful using the normal distribution. We can Z score we can calculate. Normally, whenever you are going to calculate, it will be more difficult to calculate that value. So using easily that table, you can calculate this. Okay, students. So this is all about the normal distribution. So thank you all. Thank you for listening my lecture. So anyone having any doubt, please ask me. I will discuss in the further class. Okay, students. Thank you all. Thank you.